Everybody is welcome to my YouTube channel. Today on the topics of B tree, binary tree, B tree, that is balanced tree. B tree is used for the index purpose, and this purpose of the index is so many trees is used: binary tree, B plus tree, and also AVL tree. Every binary, every searching tree is used for the index purpose. We store data at disk, mainly at disk, secondary memory, and we take data or modify data or access data or delete data for searching. That is searched by the by the index. This index is prepared by the help of the B tree or any other trees is there. But B tree is more easy and also time complexity is very less. Suppose it is a node of a B tree is showing a picture. Node means storage of the key and also the pointer. Here is a node is saying that 1, 2, 3, 4, 5. 5 key is there. Each key there is a space. This space indicates the pointer value. So many pointer is there. One pointer is key value. Pointer contains the data pointer, block pointer, and record pointer. So the pointer for the data, record, and block to indicate block, record, and data. And this is the child. This is the one child of this key. And this is the left child. This is the right child of this key. This is also a child. And this is the right child of key. And value of this left child is less than this key. Value of this right child is greater than this key. Value of this child is greater than this key and less than this key. This is also one child. This is showing the value of this child less than this key, and also this value is greater than this key. If this is A, B, C, D, E, child is, there is 1, 2, 3, 4, 5. 5 child is there. 5 node is there, and though the children is 5 plus 1, that is 6 children. That is 6 children. So children always one extra from the node. Node represent the key value and also other pointer value. And this is the child link to, it will consist another child node. So question is, how many node, how many key is there? This depend upon the order of the B tree. If the order is M, then children should be M. Matlab, this is the maximum children of M, of order M. And keys and children M, key is 1 minus order. So key value, the order is M, then key value is M minus 1. That is, order is M, so children is M. Key value is M minus 1. So 1 less than the child value of the order. Now we come from the another point, and that is the pointer. Each node consists some key, and key value is there. Also there are some another matter, that is, we have already discussed, that the value of the pointer. Now what is the pointer job? Pointer is associated with the block, also the data, also the key, next key. So so the pointer points to the next block of the child and also record of the disk. And this is the root node, where root node consists only when minimum 2 children, minimum 2 children he can associate, he can generate. So root node contain minimum 2 children. In between node, the in between of this intermediate node or middle node or branch node consists maximum M children if the order is M, but minimum M by 2 children. Minimum M by 2 children, maximum M children. And node or key is m minus 1. Maximum key is m minus 1. Minimum key is m by 2 minus 1. Minimum key is m by 2 minus 1. So this is the rules of the B tree. So minimum root at the root level to maximum root, maximum child of the root is m when order is m. And branch level, branch node consists m child, minimum children m by 2, minimum key m by 2 minus 1. Leaf level node consists no key. So B level, if at the leaf level, at the lowest level of the B tree, block pointer is there. Also there is a block pointer, but no children at the leaf level is existing. So block pointer of the existing value of this point is null. Suppose we have to enter some value. The value is showing A, B, D, G, L, M, N, O, C, E. At this node, which is this node is of the B tree node. And how this node should be entered at the B tree. This is the alphabet. So alphabetical order, we have to enter the node at B tree. First, we have to enter A. This sorting, we not done this sorting at before entering. So first we have entered two value, and second value we have to enter, that is B. B is after A, so it will take position at the right side. D is after B, then it will take position at the right side. G, A, B, C, D, F, G, G is right position because G is after D. And after G, L is coming. L is at the alphabetical position, it is right side, so it will take right side. And M, I, A, B, C, D, F, G, I, J, K, L, M. M is the right position because M is after L. M and O. O is the right position because O is after M. C is after B. So C, I have to put the C after B. I have to delete D, and I have to put the C value C. And now it is coming E. A, B, C, D, E. D is after E. So I have to erase the value of G, and at the position of G, I have to enter the value of E. So this is the short order, or this is the ascending order, alphabetical order of the node. So first we have to enter the node, and this node should be entered as alphabetical order or numeric order of the, as in case of numeric value. This is the sorted order of the node. So B tree is the balanced tree. Always the leaf node. This is a leaf node at the same level. This, if the level is 0, this is 1. This is the 0 level. Always the leaf node is 0 level. This is the middle 1 level. This is the level 2. So leaf node always take position at the lower position, and the no tree or no child at the leaf node is existing. And if and how the data is accessed from the disk to the by the indexing by index. If we see these disk is a platter, and it is divided by two ways. One is by track 1, track 2, track 3, track 4, and track 5. And another division is sector wise, that is sector 0, 1, 2, except in this way. So two way is disk is divided. One is track wise, one is sector wise, and the section, cross section, or the section point of the two subject, that is track and sector, is called block. This is the block, and this is the block. This is the block area, and data is stored at this area, and this area, this is the position to store the data. And this is the data storing capacity, data storing position. But how the data is stored? Data is stored according to the index, and this index helps to store the data. Suppose one index is showing here, and this index have pointer of the data point and also ID of the data. So data, when data is located, two parameter is there: ID, any types of ID is there, and pointer of the data location, and then data will be identified. So there is a one pointer is I am showing, and several pointers. If suppose one block contain one pointer, and one pointers have above data. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 5 pointer is required for this block. But 5 pointer take some memory, and this memory is accepted. This memory is located. This memory is utilized from the disk. So disk is the taking responsibility for pointer. Sorry, for index. This type of index is called dense index. So dense index access data from the disk by pointer, and so many dense index is there to access the data, and dense index is controlled by another index which is controlling the dense index. That is dense index. If the dense index is so many dense index is controlling the data, then sparse index is required to control the dense index. And this way the index for index is required at that level. Multi-level index is required for taking action or taking controlling power of the sparse index. So index is working to control the index. In this way, memory is memory is required to store the index, and this memory is utilized from the disk. So disk is responsible for the index memory, to locate for the index memory, but utilize for this index memory. But it is more give facility to retrieve data, to access data very easily. So it is reducing the time complexity. Index 6 is increasing, but reducing the time complexity of the to access data from the disk. The data is accessed from the disk, and it is stored at the main memory for temporary purpose, and main memory is utilized by the CPU. In this way, this index is working, and index unit as a index is working by the B tree. Suppose we have already entered some value at the node. So value is entered at the node according to the ascending order of the value of the key. And this value, so if we enter one value, first we enter the one value, second time when we are going to enter the value, we have to compare the value of the existing value. If this value is less than this value, then I have to put the value, new value, to the left side of the value. Suppose n is the variable of this key value, and so if n is less than the existing, then it will shift at left side. If n value is equal to any value, then this is a duplicate value. If n is greater than the value, then it will take position the right side of the others key. In this way, the value is entered at the node. So I am just discussed only the B tree, on discussion on the B tree, and next video I will discuss the insertion and deletion of the B tree.